Hello, in this chapter we are going to extend what we have learned in the first chapter, limits, to the derivative of a function. So the slope of a tangent as a limit, the definition is m equals limit when delta x approaches 0, delta y over delta x equals the limited value when h approaches 0, f at a plus h minus f at a all over h. This is just the slope of a secant when the 2 points they are closing to each other. So this is a value, this is a plus h value, this is x value, and f at a is a y value at that point. This f at a plus h is a y value at a plus h. So we find the difference of the y value, then subtract and divided by the difference of the x value. The difference of x value is h. So f at a plus h minus f at a, then divided by h. This is the slope of this secant. When h approaches 0, this point is approaching to f at a, f at a, and this is the slope of tangent. And now we are going to give it a more precise name. We call it the derivative of function f at x. And we are going to write it as f prime bracket a bracket and read as f prime of a. So a is the input, f means a function, f prime means a derivative of that function. So f prime of a represents the slope of the tangent at x equals a. So they are equivalent. We just gave the limit of the slope of the secant, means the slope of the tangent, gave it a name, the derivative of the function at x equals a, and the sign we use f prime of a. So in this definition is f prime of a equals just the limited value of the slope of the secant equals the slope of the tangent if the limit exists. Otherwise we don't have the derivative at that x equals a. And we are going to see one example. So we are going to use a derivative definition. So f prime, now we just want to find at any point the derivative. So we call it arbitrary value of x. So any number of x, we want to find a general formula for the derivative. So f prime of x equals just the slope of the tangent. So when h approaches 0, then f at x plus h minus f at x over the 2x value difference is h. Then we sub in x plus h to the x squared. So we have limit. When h approaches 0, we have x plus h bracket squared minus x sub in is x squared all over h. Then we expand x plus h squared represent the base times itself twice. So x plus h times x plus h. You could use a perfect square formula, or you could just use a first term times each term in the second bracket, then second term times each term in the second bracket. We are going to have x squared plus x times h plus h times x is same as x times h, then h times h. So 2 terms times 2 terms, you will have 4 terms. Then collect the like terms. So we are going to have limit h approaches 0, x squared plus collect the like term, same variable, same degree. We call them like terms. So same x, same h, the degree, no number means 1. So when you have the same like terms, we can add the number at front. So 1 plus 1, no numbers means it's 1 at front. So we have 2xh, then plus h squared. This is for the x plus h squared, then minus x squared, all over h. X squared minus x squared, they cancel out. Is 0, so we have 2xh plus h squared divided by h. We do the division. So each term we do the division. We have 2xh divided by h cancel out. We have 2x. H squared divided by h, degree subtract. When you have the same base, do the division is subtract. So 2 minus 1, you have 1. And we don't have the denominator equals 0 anymore, so we could do the direct substitution. Sub in h equals 0 to this expression. We have 2x plus 0, then we have final answer is 2x. So this is a derivative of this function x squared. So f prime x equals 2x. This is a derivative of function f at x equals x squared at a random value of x. So this is for question A. The reason why we want to have the derivative at an arbitrary value of x, because this is a general formula. For question B, we don't have to do the derivative again. We could just sub in the value of the x value to find the derivative of function at that x value, and that represents the slope of the tangent. So question B, the slope of tangent at x equals -1 equals f prime -1 when x equals -1. Then we sub in is 2 times -1 is -2. When x equals 0, we sub in the slope is f prime at x equals 0 is 2 times 0 give you 0. When x equals 2, the slope of tangent at that point for function f at x is f prime of 2. We sub in 2 to the derivative of function f at x. We have 2 times 2 equals 4. So this is how you use the definition of the derivative of a function, which is the slope of the tangent, to find the derivative of the function at each point and at each x value. And this represents the slope of tangent at this x value. So that is our first example. In our last chapter, we have discussed about the continuity. It means if the both sides, the limit of the function exist, and also the limit equals the function's value, we call it the function is continuity at that point, x equals a. And the differentiation means if the function is differentiable or not, the slope of tangent exists or not. So this one means if the limit at the of the derivative of the function, the limit of the slope of the tangent, so limit again, exists or not. So So from the left side, you will see the slope is negative, and from the right side is positive, and here the slope is vertical. It means it's infinite. So for this type of a graph, it's not differentiable. We say that the slope of tangent is not equal, not continuous at this point, so doesn't exist. The limit of the left side slope of tangent is not equal to the slope of tangent on the right side. So we call it the cusp. And for this one, same thing. So if you draw the tangent, you will see the slope is left side, right side is at this point is vertical again. So if vertical is infinity, so the slope doesn't exist. And this point is discontinuous. If it's not continuous, it's not differentiable. The reason why discontinuity, then if the function is not discontinuous, it's not differentiable, because at x equals a point, the f at a, the function's value doesn't exist. If the function's value doesn't exist, you want to use f at a to find the slope. You don't have a function's value, so you won't be able to find the slope. That's the reason if discontinuous, then the function is not differentiable. Okay, so differentiable will tell you that it will be continuous because the function at that point exists. And continuous doesn't guarantee you differentiable. So differentiable always continuous, but continuous doesn't guarantee you differentiable. So continuous, but it's not differentiable. If this continuous, then for sure it's not differentiable. Even continuous doesn't mean that it is differentiable. Okay, so we are going to see next question. We are going to see something like this: why the is not differentiable. Okay, so example 2, we are going to examine absolute value function f at x equals x absolute value. So it's not differentiable at x equals 0. So f prime 0, the slope of tangent at x equals 0 doesn't exist. So if we sketch it, you will see the absolute value function is similar with y equals x. So if f at x equals absolute value x, when x is positive, it will be equal to itself, because the definition is x value is from the point to the 0, the distance. So if the point is 3, the distance is positive 3. If we have a point at -4, the distance from -4 to 0 is positive 4. So the x value gives you the distance from that point to 0. So when x is less than 0, then the distance will be the opposite with this negative number, so will be negative x. And from this, we could graph it as x, this is y. Then for x greater than 0, you have y equals x, it's just a straight line. And if is x less than 0, is y equals negative x, so slope is -1. It will be this way. So now we are going to see the slope of tangent exists or not. So we are going to use a slope of tangent from the left side. Okay, limit when 0 plus h, we want to find the x equals 0 point the slope of tangent over h when h is approaches 0 from the right side. So this one is similar with limit f bracket a plus h minus f at a over h. Then this one is h plus approaches a from the right side. Okay, now a value is 0 because x equals 0. So we are going to sub in 0 plus h to when the input is positive, so it will be x. So 0 plus h sub into x is 0 plus h. Then minus 0 sub in is 0 all over h. So h divided by h is 1. So from the right side, the slope of tangent is positive 1. Then do the same thing to the left side of 0. So f 0 plus h minus f at 0 all over h. Because h is from the left side is negative, so we are going to sub in here. We are going to have limit h approaches 0 from the left side is negative bracket 0 plus h. If negative is negative, then we put the input here, minus 0 all over h. So minus 0 minus h minus 0 0 0 gone, minus h divided by h, you have negative 1. Then you will see for the slope of tangent, the left side limit is not equal to the right side limit. Is not equal to the left side. So the limit doesn't exist. So limit doesn't exist. Limit h approaches 0 for this one, minus f at 0 over h. This is a slope of tangent, and this slope of tangent equals f prime 0. It's just another name for the slope of tangent. This doesn't exist, so f prime 0 doesn't exist. So that's the reason the cusp is not differentiable. So if the f prime doesn't exist, then f at x is not differentiable. It's not differentiable. Not differentiable, it just means the slope of tangent doesn't exist at that point. Then the question B asks you state the domain on which f at x is differentiable. So domain is a x value. So f prime x differentiable domain will be, in the set notation, x belongs all real numbers such that x is not equal to 0, because all the other points, the slope of tangent exist. So this is for the example 2. Then we are going to practice one more example. And you could pause the video at any time and rewatch them if you have any questions, you want to watch it again. So for this one, find the equation of the normal. So this is another term. The normal is just perpendicular to the tangent of the graph. At x equals 3, for f at x equals 1 over x. So if you still remember from the grade 11 functions or grade 12 functions, 1 over x, it is 2 branches. So x equals 3, then the y value is just sum in, you have 1 over 3. So this is a point, and the slope, if we draw it, will be touch the graph only at one point. The normal, it means perpendicular to this line. This is normal. It asks you to find the equation for this normal. This is a straight line, so we need to find the M and B. In order to find the normal slope, if we could find the slope of the tangent, then we are able to find the perpendicular one. Okay, so our thought is step 1, we want to determine the slope of tangent at x equals 3. So if we write it as a derivative of a function f at x, it will be determine f prime at 3. So this is equivalent with a slope of tangent at x equals 3. So it's easier for us to write as a derivative of function f instead of the slope of tangent or the limit. So that's the reason we want to use a derivative of a function f prime. It's just concise form notation for that. So in order to find this one, we are going to write the definition of the derivative out. So f prime x equals slope of tangent. So h approaches 0, f bracket x plus h minus f at x all over h. So in last chapter, I didn't show you, you could put a 3 here because I want you to put x there, then after that you will have a general formula. Another way you can do it, you just put a 3 here. So I will show you, just put a 3 here, you will, so f prime 3 equals limit h approaches 0, then f three plus h minus f at 3 all over h. Then we sub into the given function, we have limit h approaches 0, 1 over 3 plus h. If the question asks you for more than one point the slope of tangent, then don't sub in the x value, just keep the x arbitrary x there, random number x there. Then it will be easier for you to find more than one slope of tangent, because later you can just sub in the x value. If you only find one slope of tangent, you could just sub in the x value. So 1 over 3, then all over h. So for the fraction subtraction, we are going to need to find the common denominator. so it will be cross times. So the common denominator will be 3 plus h, then times 3. So it means you have to times 3 plus h, 3 to both top and bottom, and times 3 plus h to both top and bottom to get the common denominator 3 plus h. Once you have the common denominator, you could just subtract or add the numerator. So 3 minus bracket 3 plus h. Then we are going to simplify. We have limit h approaches 0, then h, 3 bracket 3 plus h. 3 minus 3 plus h, we have negative h. Then continue limit h approaches 0, so negative h over 3 times 3 plus h. We want to change the denominator to division becomes multiplication by flip the denominator, so times 1 over h. Then we are able to, because it's multiplication, so they are factors. Then we can cancel the numerator denominator by divided h to both top and bottom. Then after that, you will see you are going to get rid of the denominator h from the denominator. Then you don't have 0 at the denominator. We could do the direct substitution. So h equals 0, sub in, we have 1 over 3 bracket 3 plus 0, we have 1 over 9. And from this 1 over 9, we are able to find the, okay, so negative 1 here. So we have negative 1 over 9, then the slope of the normal will be negative flip, will be positive 9 over 1. So this is your normal slope, slope of the normal. And it asks you to find the equation of the normal. So what you are going to do is, we have the slope. We are going to need a point in order to find the b value. So in this equation, you have y, m, x, y. You have 4 variables. In order to find b value, we need 3 given. And these 3 given, we have the m perpendicular. We need x and y. So x equals 3, then the y value we sub in to the reciprocal function will be 1 over 3. Then what we have to do is substitute this to the slope y-intercept form. We are going to have 1 over 3 equals 3 times the 9, then plus b. In order to solve for b, we are going to isolate b. We have 1 over 3, then subtract 3 times 9 is 27. We do the simplification. You are going to have the same denominator, so times 3. Then simplify is negative 80 over 3. Then the final answer will be y equals 9x minus 80 over 3. So that is the slope, the equation of the normal. So here you need to know how to find the slope of the tangent, then negative, flip over, then you are going to sub in the x value to the original function to find the point. Use mxy, sub in, you solve for b. So, and in this lesson, what we have learned is the derivative of function is just the slope of the tangent. So, and the slope of tangent, we call it the derivative of the function. If a function is differentiable, it means the slope of tangent exists at that point. So the cusp, vertical tangent, and the discontinuity, these three common scenario, the derivative doesn't exist at that point. So if differentiable, the function will be continuous. But continuous doesn't guarantee the function is differentiable. Continuous means the limit of function at that point equals the function's value, then it's continuous. Differentiable means the derivative exists at that point. The slope of tangent from left side, right side limit, equal. Okay, thanks for watching.